Part A. 1. The company specialized in high-tech electronic gadgets. 2. A new smartphone model was introduced. 3. The smartphone model was launched in 2018. 4. At the time of release, there were 500,000 active users. 6. The number of users have been declining exponentially over time. 7. By 2023, only 120,000 users remain. Part B. 1. A detective arrives at a crime scene. 2. The body was discovered at 9 a.m. 3. The temperature at noon is constant at 20 Celsius. 4. At 9 a.m., the victim's body temperature was 32 Celsius. 5. At 11 a.m., the body temperature is 30 Celsius. 5. 6. The victim's temperature was 37 Celsius at the time of death. Ideas. 1. Use formula of radioactive decay, which is NT, same NOE negative KT for part A. For 2. Use formula of Newton's law of cooling, which is T, same TE plus TO negative TE, E negative KT for part B.
Learning issue for part A. What is exponential decay and how does it apply to real-world situations like user decline? 2. How can we use the exponential decay formula to estimate the number of users in future years? And 3. What are the common reasons for a decline in users of high-tech products over time? Next, for part B, what is Newton's law of cooling and how it is used to estimate time of death? 2. How can we use the body temperature at known time to estimate how long ago death occurred? And 3. How is the value of K determined using two temperature readings and time difference?
Action plan for part A. Number 1. Study the exponential decay formula and understand how each variable relates to user data. Number 2. Collect real data of user decline from 2018 to 2023 to calculate the decay constant K. Number 3. Use the decay formula to predict the number of users in future years. Number 4. Research common factors that cause decline in user of high-tech gadget competition, audit stage, market trends. Number 5. Create a graph showing the trend of user decline and future prediction for visual representation.
Action plan part B. 1. Learn and understand Newton's law of cooling and how it is applied in forensic cases. 2. Substitute known values, body temperature at 9 a.m. and 11 a.m. ambient temperature time difference into the formula to calculate decay constant. 3. Use the formula again to estimate time of death using the calculated value of K and body temperature at 9 a.m. 4. Research real forensic cases where Newton's law of cooling was used for practical understanding. 5. Present your findings in a written or digital report explaining the method and time of death estimation process.
For solution part A, we use NT equal to N0 multiplied by E exponent negative KT. Given NO equal to 500,000 and N5 equal to 120,000, then we have to solve K by taking the natural logarithm on both sides. So, model is NT equal to 500,000 multiplied by E exponent negative 0.28540. Then predict the number of users in 2026, which is 8 years after. So the final answer is NT equal to 500,000 multiplied by E exponent negative 0.2540 and NA equal to 51,050 users. So the numbers will drop. used below in early 2026.
For solution part B, we use the formula of Newton's law of cooling formula, which is T equal to TA plus TO minus TE, multiplied by e power of negative kT. We know that 9 am T1 equal to 32 degrees Celsius, which is T, and at 11 am T2 equal to 30 degrees Celsius, which is T plus 2. Hence, we will get T equal to 3.83 hours. So, the exact time which the murder took place when the victim's body temperature was 37 degrees Celsius is at 5:70 am.
Question C also shows that mathematical model may be successfully analyzed in two different contexts. One of them is in the sphere of technology and the other one is crime investigation. Part A involves a model of exponential decay to find the number of active smartphone users reducing between the years of 2018 and 2023. This model has enabled us to forecast the amount of users in the years 2026 and has also been in position to estimate the time after which the number of users will get to be less than 50,000. The insights of such prediction are of benefit to companies in their business planning. Part B in Section B, Newton's law of cooling was used in estimating the time of murder of a body using the temperature of the body. The method gives invaluable detail in forensic study and may help the police to create a criminal case. On the whole, this question demonstrates the relevance and applicability of mathematical model in various disciplines, as it allows making more accurate prediction and assessment and making decisions in business and in the field of forensics.
For conclusion, with the help of this project, we have used the theory of exponential decay and Newton's law to solve the two real-life problems in falling away of smartphone users and estimate time of death in a forensic case. In Part A, Question 6, we were able to obtain the exponential decay model to estimate the declining number of the smartphone users with time. By measuring real data, we were able to find the decay constant and come out with a mathematical model. This model allows us to tell how many users we would have in the future and how much time it would take to see this number go below a given number. We found out that by 8 years after the launch of the phone, the user base would have declined to just less than 15,000 people, and this explains how quickly technology becomes outdated in a competitive world. The law of cooling developed by Newton, also referred to as Newton's cooling law, was used as a method to estimate time of death using two register body temperature and fixed action temperature. In Part B, Question 6, we determine the time of the death by solving the exponential temperature declining equation. The outcome of our finding indicate that the victim died at about 5:17 am, about 4 hours prior to its discovery, indicating the fact that mathematical modeling could be effective during the process of criminal investigation. On the whole, the experiment helped us improve our knowledge of the theory of the first-order differential equation and their possible application in the technological and forensic field. It also improved our critical thinking and problem-solving skill because we could relate theoretical knowledge with real-world situations.